Hello everyone, my name is Katerega James. I'll be taking you through Foundry technology. Welcome to our YouTube channel. Don't forget to subscribe or click the like button if you are interested. You can even comment for your views. We shall reply instantly. So, like earlier before, we looked at Foundry technology, whereby we looked at the introduction, the different, what is involved with Foundry practice, and all that. This time round, we are going to look at what is pattern making. What are patterns? And to start with, you have to know what are the different definitions of a pattern. A pattern is just a model. It's just a replica of an object made by the casting process. Like earlier I said before, that a casting is the final product of what we call the Foundry practice. So when it comes to patterns, they can be made of either softwood like pine, they can be made of hardwood like mahogany. So the different materials we make out of patterns, we can use wood like softwood or hardwood. Like I've said, we can use plastics like bakelite, which fall under a category of thermoset plastics. We can look at metals like aluminium. We can look at metals like steel. We can look at metals like cast iron itself. So wood patterns must be made of either dried wood or seasoned wood, especially when you're looking at wood patterns. When it comes to seasoned wood, this is wood that has been dried under certain conditions. It's whereby wood has been placed in either a room and dried seasonally. So we have to make sure that our wood contains less than 10% moisture, and this will either pass to avoid what we call warping and distortion of the pattern. We have to make sure that the moisture is not absorbed during the preparation of the moldy cavity from the molding sand, and this will help us that our pattern will produce a sound and smooth casting. We have to make sure that our pattern has to be painted and coated with waterproof varnish for easy storage and preservation. So that is all about what a pattern is going to look like. So what are the different functions of the pattern? What role does a pattern play when it comes to sand casting, when it comes to Foundry practice? So one thing we need to know, one of the functions is that a pattern is essential for the production of any metal or any alloy. Whenever you need to create any alloy, you need to create any metal out of the Foundry practice. Make sure that a pattern is very essential. Once you don't have a pattern, that means you're not going to have an output of the product of the casting process. Then you have to make sure that a pattern is used to produce a cavity in the molding sand for pouring the molten metal. A pattern is done that creates what we call a moldy cavity. And you also need to know another function is that the properly manufactured pattern reduces the overall cost of casting. Once you have a pattern, it will enable you to create what we call multiple moldy cavities. You reduce the overall cost of creating every time a pattern that will keep on incurring more costs when it comes to casting. Then a properly manufactured pattern reduces the casting defects. There are many defects that come as a result of poor patterns. Porosity defects, we are going to look at those defects in details, but we need to know that a pattern is then responsible for producing or reducing those casting defects. A properly manufactured pattern produces good surface finish for the casting. Once it is a smooth and sound pattern, that means the surface finish is going to be very good. Then a pattern may have a projections. This projection may be known as core prints, and these help us in the positioning of the core, because we know very well that a core is used for creating those hollow sections on our castings. Then a pattern also establishes what we call a parting line. A parting line is this line you see here. For example, this is a two-piece pattern, a wood two-piece pattern. This is what we see here. What you see is what we call the parting line. And when you split it like this, since it's a two split pattern, this is what we call a parting surface. So a pattern is responsible for establishing what we call a parting line and parting surfaces in the mold. Then we are going to see that also a pattern sometimes may provide what we call a runner. Some patterns provide runners, they provide gates, they provide risers. Like I said earlier, that a riser acts as a reservoir, whereby molten metal is fed in order to pass through into the moldy cavity. I'm getting it. So those are the different functions of a pattern. Then we have to look at how do we make these patterns? We've seen their functions, but how do we make them? So just like any other material, like wood, it is made by the wood is worked upon by the carpenter. So even patterns, they are made by the carpenter at the carpentry shop. So what are the different tools we use when making patterns? So we have marking and measuring tools. Marking and measuring tools, here is where we have the tri-square, the bevel square, the straight edge, the meter square, the combination set, the scriber, marking, and so forth. Those are marking and measuring tools. We look at the cutting tools. We have the chisels, we have the saws, we have the files, the planing tools, axes. Those are etc. Those are cutting tools. We look also at what we call the boring tools. Boring tools is where we have the gimlet, we have the ratchet, we have the brace, we have the wheel brace, the brand wheel. Those are boring tools. We look at the holding tools. These holding tools is where we have the G clamp, the C clamp, and the hand screw clamp, the bench vise. All those are holding tools. Then we can't talk all about those tools without looking at what we call the miscellaneous tools. What are these miscellaneous tools? The miscellaneous tools, these are tools that are used for making a lot of functions. This is where we have the screwdriver, is where we have the glass paper, is where we have the oil stones, is where we have the scraper. Those are miscellaneous tools. They are also used when it comes to making a pattern. Then, having looked at those different tools we use during the design and the making of a pattern by the carpenter, we also have to look at what we call the pattern designing considerations. The quality and the accuracy of a casting will always depend on pattern making. Therefore, we need to know that a good designed pattern may produce a smooth and sound casting, but a bad pattern will always result into a poor and defected casting. So what are these factors do we consider when designing a pattern? So one of them is the proper material selection. We've looked at wood, we've looked at metal, we've looked at plastic. So when you look at those different materials, each material has its advantages and disadvantages, but it will depend what type of pattern do we need in order to select a material suitable for such a casting. So a proper material, we can talk about metallic patterns. These ones have certain advantages. They have good strength, they have good surface finish, they have good dimensional accuracy and stability. So long life, they also have a long life, but expensive than hardwood patterns. So we have considered the material being metal, it is advantageous compared to wood. Then we have another factor to consider, proper type of pattern. What type of pattern are we going to use? There are many different types of patterns. We need to know that a proper type pattern should be used for a particular application. For example, we have a match plate patterns are best suitable for machine molding, where both match plate and gated patterns are recommended for producing smaller components in mass production. So we need to know what type of pattern. There are many different types of patterns. The two-piece pattern, the single-piece pattern, the solid-piece pattern. But we need to know what type are you going to use for making, what factor are you going to consider when designing a pattern. Then we have what we call pattern allowances. Also those have to be put into consideration. This is where we have the shrinkage allowance. This is where we have the draft allowance. This is where we have the machine allowance. All those allowances have to be put into consideration. We know very well that in order to attain the dimensional accuracy of a certain casting, we need to know we have to put into consideration the machining allowance. It's, for example, if I have measurements of this diameter and it is 5.2, that means the 0.2 millimeter is for the machining allowance for us to acquire the exact dimension, which is 5 millimeter. Then you have to also take note that dimensionally accurate and stable. We have to make sure that our pattern, when we are considering, we have to put into play that the material we are using has to be dimensionally accurate and stable. So a pattern should be dimensionally accurate and stable. This should have good surface finish. We have also to take note that when we are designing our pattern, we should always avoid what we call sharp edges. So a good pattern should be round, sound, smooth, in order to provide a good surface finish. Because we know very well This will permit easy removal of the pattern from the molding box. It also is a smooth and is a smooth flow of the molten metal into the mold cavity. Then it produces good castings. So all these have to be put into consideration, because once you avoid these sharp edges, these are the good things you're going to be getting out of your casting. Then we have what we call core joints. Core joints should also be avoided. Core joints should be preferably be avoided in order to obtain uniform holes. Then the position and the size of the core prints also has to be put into consideration. So core prints provided with a pattern should be able to optimize size and suitably be located. Then you also have to look at the core code, the color code and storage. So all those patterns used for repeated working should be coated with preservatives like varnish. They should be properly color coded. We have different colors we code the patterns: red, black. What do they mean with respect to patterns? Then we have to store our patterns in a well airflow preserved area. Then we can talk about the maximum portion should always be in the drag. Like I said earlier, that the drag is the lower part of the flask and the cup is the upper part of the flask. So you have to take note that for split patterns, the parting surface should be such that the maximum portion of the pattern remains in the drag. Then those are the different factors to consider when designing a pattern. Let's get a glimpse of what are the categories of patterns. There are categories of pattern. There are also types of patterns. But here I'm going to look specifically at let's first look at what are the categories of patterns. So categories of patterns, we have what we call reusable patterns. For sand or plastic casting, which make impressions into the molds, here we make use of the reusable patterns. The reusable patterns are used multiple times. You use it today, you keep it, use it the next day. Then we have what we call expendable patterns. So we are going to see that expendable patterns, these come about when we're dealing with what we call investment casting. So that this investment casting, in this case, we find that our pattern is destroyed during the process of making a mold. It melts away, like wax, it melts away. So that is also a category of a pattern. There are other categories like investment patterns. They also make use of the wax. These melt and evaporate away. Then we have sand casting patterns where we have wood, metals. These are made of hard material that can be used to create hundreds and thousands of castings. They are inexpensive to make. They can make large castings. So those are sand casting patterns. That is another category. But these are not types. These are categories of patterns. We shall look at the different types of patterns slow by slow. Then we have what we call storage of patterns. How do we store our patterns? Patterns must be stored in a dry place with a good air flow, especially wood patterns, because we know very well that once moisture gets into contact with the wood, that means we expect things like warping and distortion. Then when it comes to metals, we expect them to rust. But once we place them in a good airflow area, which is dry without moisture, they are going to be well preserved and kept for future use. Then that was all about our second lecture. Then other topics to come in the following presentation, whereby I will be interacting with you. We shall look at the different types of patterns, coding of patterns, molding sand preparations, tools and equipment used in preparation of the mold cavity for sand casting. Don't forget to subscribe to our YouTube channel. Thank you for listening. Thank you very much.